what if the very first stars in the universe weren't actually stars at all? Today, we're going to dive into a cosmic mystery that could completely rewrite the story of the universe's first light. And it all revolves around this strange theoretical object called a dark star.
You know, when we pointed the incredible James Webb Space Telescope at the farthest, earliest corners of the universe, we were expecting to see these faint, first flickers of light from the very first galaxies. But what it found, well, that was something else entirely.
The telescope spotted objects that were just way too massive, way too luminous, and showed up way too early in the universe's history. According to our best models of how the cosmos works, they simply shouldn't be there. It's a huge puzzle, and scientists are, frankly, scrambling to figure it out.
Okay, so what exactly did the JWST find? Let's break down this cosmic anomaly that has the entire astronomy world buzzing.
Pretty much everything about these objects breaks a cosmological rule. First off, they're at a redshift of 10 to 13. Just think of redshift as a cosmic timestamp. It tells us we're seeing light from just a few 100 million years after the Big Bang. Now, instead of seeing fuzzy baby galaxies, the telescope saw these single, super compact points of light. And their mass? It's just staggering, up to 1 million times the mass of our own sun. The thing is, according to our standard models, there just wasn't enough time for anything to get that massive, that fast.
So, to try and solve this crazy puzzle, scientists have dusted off this, well, it's a fascinating, almost science fiction kind of idea, the theory of dark stars.
Now, the first thing you need to know is that a dark star isn't dark at all. In fact, it would be incredibly bright. The dark part of its name? That's all about its fuel. See, while our sun is powered by fusing hydrogen atoms together, a dark star would be powered by dark matter. The idea is that inside the star's core, dark matter particles would be crashing into their antimatter twins and poof, they annihilate each other, releasing just a colossal amount of energy.
And when you put them side by side with our sun, the differences are just mind-blowing. Forget nuclear fusion. These things run on dark matter. They could swell up to 1 million times more massive than our sun. And they wouldn't be these hot, dense balls of plasma like we're used to. Nope. The theory says they'd be relatively cool, incredibly puffy, and unimaginably large.
So just how huge are we talking about? Well, a large dark star could have a radius of 10,000 astronomical units. To put that into perspective for you, Saturn's orbit around our sun is about 10 AU. You could literally fit our entire solar system, all the way out to Saturn, inside one of these things, 1,000 times over. They would be true cosmic behemoths.
Okay, but here's where this theory gets really compelling. It's not just that it explains these weird new objects. The truly amazing part is that if dark stars are real, they could solve some of the oldest, biggest puzzles in all of cosmology.
This one idea, it's like a silver bullet for 3 huge problems. First up, supermassive black holes. How did they get so big, so fast? Well, when a dark star finally runs out of fuel, it would collapse straight into a massive black hole, the perfect seed for growing the giants we see today. Second, the first stars. This gives us a whole new candidate for the universe's very first luminous objects. And third, cosmic reionization. Their incredible, sustained brightness could have been the engine that burned off the fog of neutral hydrogen that filled the early universe, lighting everything up and ending the cosmic dark ages.
But look, this isn't just some fun idea on a chalkboard. There is an active hunt going on right now to find definitive proof.
To prove they're real, astronomers are looking for a very specific set of fingerprints. The light from these things would need to show they're made of only the universe's original ingredients, hydrogen and helium. But the real smoking gun, the thing that would seal the deal, is finding a unique spectral line from helium, a telltale signature that's just really hard to explain with any other object we know of. And get this, we already have candidates. These 3 objects spotted by the JWST are our prime suspects right now. They're in the right place, they have the right estimated mass, and they look like single points of light. So now they are under some seriously intense scrutiny. And this hunt has a really clear roadmap. Right now, JWST is performing spectroscopy on them, basically breaking their light down into a rainbow to read their chemical DNA. Soon, the Roman Space Telescope will hunt for even more candidates. And by the end of the decade, the extremely large telescope is going to give us an even sharper view. So you can see how all of this is building to a really critical moment. We're on the cusp of getting a final verdict on whether these cosmic ghosts are actually real.
And it could all come down to a single clue. If astronomers can spot that specific helium absorption line in the light from one of these candidates, that's it. That's the smoking gun. It's a piece of evidence that would be incredibly difficult to explain as anything but a dark star.
And the crazy part is, we might not have to wait very long at all. The analysis on the #1 candidate, JWST Z13-0, is already happening, and we could get results in just a couple of years. We are right on the verge of a potentially massive discovery. So what happens if they're confirmed? I mean, what's the big deal? Well, the impact would be nothing short of revolutionary. Not only would it solve this initial mystery from the JWST, but it would also confirm those 3 huge cosmic solutions we talked about, giving us the seeds for supermassive black holes, a new type of first star, and an engine for reionization. It would fundamentally change the first few chapters of our entire cosmic story.
So the question this leaves us with is, well, it's profound. For decades, dark matter has just been this shadow, right? This invisible influence we can only detect by its gravity. But if these candidates are confirmed as dark stars, we won't just be seeing the universe's first light. We will be seeing dark matter in action for the very first time. And that changes everything.